Yes, hello everybody. Macroeconomics at first, standard advertising for the start, and you see here that Mr. Ran, uh, yeah, tries to come at Thursday 14th, then same time, same place, and hopefully it will work then. And then I want to advertise my own talk I will give tomorrow. This is no new one. Tomorrow is the career day of the Jade Hochschule. Maybe you have planned to go there, and I was asked to give a talk about artificial intelligence. Well, I directly dealt with the topic when ChatGPT came out in November last year. Unfortunately, then for somehow half a year, I haven't done that much with the tool. And last week I was going to Düsseldorf by train, and then I sat opposite a young guy, a student, and this was really fascinating because he really used it in the way I would recommend to use this thing. But well, and this is the experiment I will do tomorrow, because this weekend I thought about it, and I dealt with the topic artificial intelligence, labor market, and education in special. And then I thought, well, I give you some numbers, some ideas, and some general and whatever. And then I thought, well, let's try it just live, that I try to work out my own talk with you together. And because this is the thing this is my idea how artificial intelligence will change our whole life, and especially will change education. And I don't know if it works, but this I will try. So maybe if you have time, participate. Okay, so then back to right now. At some parts of this lecture, I also used already artificial intelligence, because of course English is not my mother tongue, and therefore in order to translate some parts of my lecture, I use, where is it? The, in my eyes, best translation software, and this is of course using artificial intelligence. And I asked also some people who really know it, and they said, well, it is almost a translation like a native native speaker would say it. And so this is already something which I use here, but in general it will change education at many other points, I suppose. So then back to content, but what artificial intelligence until now is not possible to do is really to create especially new ideas, and also without the correction of a human being to produce an output which is in quotation marks correct. So this is what I have to say until now. So then back to our topics in special. We have started with our first theoretical model, the so-called Keynesian cross, and let's just step into no. So then I will just create it live because I have written that much within the diagram that I want just to remind you what we have done last time within this diagram. That our model meant that we made some strong assumptions and that our economy is driven by the demand. So we are planning our demand, YD, demand side of the gross domestic product, and the component of this are C plus I plus G. Well, in the actual situation, G has to be recalculated by our government right now because 60 billion they have lost. And there you see in our model, we assume that government expenditure is just a fixed number because it is strictly planned for the next year, for the next 2 years by the government. And we are also planning our consumption and our investment. And up to now, we are assuming that also investment is fixed, and the motivation of this is also that we are playing for a longer time our investment, or the aggregate investment are huge investments, and this are planned for a longer time. And this is also the assumption. This model is a short run model. This does not apply for a period of 10 years or something like this. So at this point, later on, we will make these investments depending, of course, on interest rates. But right now, it is also a fixed number for us. So the only variable in demand is our consumption plan. And this we make dependent on our income itself. And we assumed that consumption is just a fixed number, the autonomous consume times marginal propensity to consume times the income, and this one is a number between 0 and 1. And what does this assumption mean, especially this assumption? This means if we have an additional euro, then we are directly spending the amount of CY, the marginal propensities to spend, from this euro. So I give you €1, and if it's roughly 90%, what is the number for Germany and what is roughly the number for developed countries, you just walk out and you are spending 90 cents of this €1 you have got. So, and a demand-driven economy means that the supply is following directly these plans. We assume that these consumption, not this consumption, these expenditure, which we are planning, are fully met by the production. And really, really important, without changing prices. You don't find prices within this model. This is also a very strong assumption that prices do not adjust, but also, especially in the short run, this assumption is quite okay if we especially assume that production supply depends mainly on labor, and labor market prices, wages, are not adjusting that fast. Because you have always these struggles also right now within our railway sector between the supply and demand side of labor, and then quite often there are fixed contracts for the next year, for the next 2 years, something around this. So no price adjustment. So, okay, sorry. That this demand equals in equilibrium supply. So this is supply, demand, production, or income, and this is our planned expenditure. And this equality is met without price adjustments. And therefore, this you have also to keep in mind, this is a short run model. Well, and with this, we have everything together, because now we go to our diagram, and then we just look, what do we have? Here, we have just a simple function, a linear line, cutting the vertical axis at C0 plus I plus G, because all these are fixed numbers. And let me remember you that this autonomous consumption is only due to the fact that then the average consumption is decreasing if Y is decreasing, and this has nothing to do with any existence minimum or anything else what you find for an explanation in the internet. Okay, then this assumption that this marginal propensity to spend is below 0 means that we have here a linear line with a slope larger than 0, smaller than 0, and then we take, so to speak, this equilibrium condition also mathematically just as a function. This we can write as y d is a function of y itself. Okay? And this is a function with cut of the vertical axis at 0 and slope 1. Okay? This is quite important. It is, yeah, on the one side, it is very easy. On the other side, I always see that, yeah, somehow it's hard to imagine. So this is maybe the, if you keep out a constant as a function, this is a more or less simplest function you can think of. And this linear line with slope 1 starting in the origin, we also draw in our diagram. So this linear line starting in the origin with slope 1. So this we can write 0 plus 1 times y. This is the origin, and this is slope 1. Well, and what does this condition represent? Well, this represents all possible equilibrium points. All possible equilibrium points where supply meets demand. And then we feed in also our explicit modeling of demand. And then this selects us our specific equilibrium, income equaling production. So the cut of these two lines is then our equilibrium income. Well, and then we can make economic policy within this model. And especially right now, due to the actual situation, we turn it just in the other direction. Let's do it in red. Assume government expenditure is cut by the High Court of Germany by 60 billion euro. Well, this would have been a very nice question in an exam, I think. So, question. What happens within our model graphically? Up at the chat. Where is the chat? Where is it? Oh, there it is. Yes, question. Yeah, the lecture tomorrow is, or my talk tomorrow is in German. But since I make this live experiment, maybe it's also something for people with when the German is not, you are not speaking fluently German. So, but back to our question. What happens within this model when government expenditure is cut by just some amount or of 60 billion, or if we reducing government expenditure by delta G? So the first thing we have to do is, where do we find within our model government expenditure? Yes, here it is. So we find it within our demand function. So we find it only in this part here. And now we have to ask ourselves what happens. So then in this case to our function yd. And what happens especially here graphically within our model. Yep. Yes. A parallel shift down of yd. So here C0 plus I plus G minus delta G. Well, and what does it mean? We obtain a new equilibrium, Y star prime, which is lower than before. And now we go to an example that we also want to know what happens quantitatively. And for this, we use just these example numbers, and due to the actual situation, we take a decrease by 60. So, and what we shall do here is also calculate equilibrium income, income before and after the cut in expenditure. Where is my mice? There it is. So what did we had? Let's take the numbers. And there it is. So please help me. Equilibrium before. So we don't care right now about the reduction. So what is the equilibrium condition? Yeah, so name it. Name them. Yes, so yd equals c plus I plus g, and you were totally right. 100 plus 0.8y plus 400 plus 200, and this has to be equal to what? Internet. What was the equilibrium condition? Yes, and this is just y itself. This has to be y itself. This is our equilibrium condition. Supply meets demand. So let's put it just here. And now I'm working with this one. And this we have just to solve for y. What do I have to do if I want to solve this for y? This I just, yes, so please, what do I have to do? I'm really struggling with my son. He's 13. I give them, he's right now doing this. And I really have to struggle with him. Come on. Please, this is class 8 in school. So 700 plus 0.8 times y minus 0.8 times y is 700 equals y minus 0.8 times y. Keeping out of the brackets, law of distribution, class 4 in mathematics. A plus B times C is AC plus BC. Okay, and this we take just the other way around. Equals y times 1 minus 0.8. Dividing by 1 minus 0.8 is 700 over 1 minus 0.8 equals y. This is our equilibrium income. So 1 over 0.2 is the same as multiplying with 5. Equilibrium income is 3,500. Let's draw it. Y equals YD. YD equals 700 plus 0.8 times Y. 700, 3,500, 3,500 equals Y star. Equating two linear lines, this should be really possible for you. And if I remember it right, the guys of you who participate within the tutorial, this was the first question I posed. So, now reduction of government expenditure by 60. Again, what happens within our model? This we discussed. This is just dropping down to 640. YD prime 640 minus 0.8 times Y. Well, what do we have to do? 640, 640, 640. Y star prime is 5 times 640 equals to 3,200, or actually this is just a new question also for me because I just invented it. Or I just changed the number a minute ago. So, this means reducing G by 60 reduces Y by 300. What an impact. Think about this. If our economy is working like this, what will happen the next time? A decrease of GDP initiated by a cut of 60 billion means a decrease of 300 billion. This is roughly 10% of our GDP. We really hope that this is not working like this. And of course, we have here a very conservative assumption about the spending. We only spend 80% directly in consumption. What would be the reduction if we feed in here the more realistic number of 0.9? This is really nice. We are great that just the decision of our High Court was some days ago. So, increasing CY from 0.8 to 0.9. What would be then the reduction? Pardon? 2,900. It doubled. Yes, definitely. And why does it double? Well, the reduction especially actually is not depending on our, so to speak, starting point here. Because the reduction is just what? It is just is delta G over 1 minus Gy. And so this would be then minus 60 over 1 minus 0.9 is minus 600. Yes, for sure. Yep. Oh, sorry. This is of course. Yeah, yeah. Sorry, sorry. You are. This was has to be a plus sign, of course. Thank you. So this here is our government expenditure multiplier. We deduced this, remember, in the lecture via the geometric series here. Of course, within our model, we can do it also in another way. Think of, this is C0, this is I, this is G. So this 700 here is C0, I plus G, and this one is CY. So what in the end do we obtain here? This 700 is in general, if we do not know the numbers, just C0 plus I plus G. This is CY. So in general, at the equilibrium condition, we obtain C0 plus I plus G over 1 minus CY equals equilibrium income. And now we can ask what happens if this one is changing. Because this is the question. If the High Court steps in and cuts government expenditure by 60 billion euros, then we are externally changing this fixed number. Remember, we have assumed this is set by the government. And this feeds in just by a fixed number. This is then called a so-called exogenous variable. So in general, C0, I, G, and Ci are exogenous. These are just set. This is building the framework of our model. And then Y is endogenous. This is calculated within the model. And now we ask, after we have calculated the general equilibrium condition, what happens if G is changing? What are you doing mathematically if you ask what happens if some variable is changing? There's some special thing you have introduced, I think, then in class 11 in school. If I change one variable by 1 unit, what happens to the value of the function itself? And this is what? Yeah, the first derivative, nothing else. So what we are doing here is then calculate the first derivative of y star with respect to g. Because what do we have here in general? In general, we have here a function which is depending on these 4 exogenous variables. And this you really should try in your studies, that you start to think here not always, well, I have to feed in explicit numbers. You really have to think about these functions just with the letters. And what happens to my function if the letters or the variables which are represented by the letters are changing? So this is a function y star of c0, I, g, and cy. And now we are calculating the derivative cy star with respect to g. And what is the first derivative? Well, if we calculating the derivative only with respect to one variable, then we are assuming doing this that all other variables are constant. This is called partial analysis. This is now a fixed number. The derivative of a fixed number is f of x equals 3. What is f prime? 0, of course. So this falls apart. Derivative I is also a fixed number, falls apart. What we only have to keep in mind is this part here. G divided by 1 over G divided by 1 minus Cy. If f of x is x over 1 minus a, and a is a constant, what is f prime of x? Just take it here. This is the question. F of x is x over 1 minus a. What is the first derivative? Well, if we say set a is 0.9, then if a equals 0.9, then we have here f of x is just 10 times x. What is the derivative? Of course, it's 10. And in general, constant times x. And what is the constant? We have here a function constant times x. And what is our constant? What do I obtain as a result? No, no. This I can write also as 1 over 1 minus a times x. Please, guys. This is a constant. Constant times x, and the derivative is the constant. So 1 over 1 minus a, nothing else. So this is 1 over 1 minus cy. And this is again our government expenditure multiplier. Please, this is not that hard. These are very, very simple functions. Everything is linear in this case. So, and of course, this should be the case. Think of this here. Here, we derived it in the same way. Government expenditure multiplier was here 10 is 1 over 1 minus CY. Yep. Well, that you remember this, then government expenditure multiplier dy over dg, or in differential, oops, is 1 over 1 minus cy. And this is the central outcome of this model. Well, it means, on the one hand, if we drop into society €1, we have a high expansion, but on the other side, if we have a cut, the expansion is as high in the other direction. Whew. Now I have to speed up a little bit. I thought this we could do within 20 minutes and not in 40. No, 60. We have now 40, almost 40 minutes. Well, you are doing, you can do in the tutorial, and we will do also in other exercises this. Well, what are then the general consequences of this very simple Keynesian model? This in general means that disequilibria over time are really possible because our price adjustment process is not that fast. And in practice, then we assume that production is following the demand, but in practice, of course, this also takes time. And this then means that in general, if demand is in general too low, that this then implies that we have in general a high unemployment level. And from this thinking then, as an economic advisor, if I assume that the economy is working like this, then I really can recommend, well, you have to step in via the government in order to push the economy. Or on the other hand, it could be the case that our economy is generally overheating. If we always think that directly prices can adjust, then the economy is regulating itself by starting high inflation or dropping prices. Well, but if we think, of course, a good Keynesian economist wouldn't say that prices never adjust. Of course not. But if we in general assume that the price adjustment process is not that fast, then we really can derive from this model that we always have to somehow re-steer our economy externally via the government. So in this case, we then can state that economy needs always external interference. Well, and in the end of this lecture, I will also show you then the opposite view. And these guys then say, well, please supply us the framework that the functions are, that the markets are functioning, and then step out of it. Okay. How much time do we have? Another 20 minutes. Okay. Then, until now, we have this. Oh, there's also an if missing. Said that especially investment is a fixed number. So right now we have no prices, demand oriented, and only adjusting via the quantities. Well, we are in a developed country and we have talked a lot about money markets, about capital markets, financial markets. So a good model, of course, then should incorporate the money market. And what we now are doing is we are adding the money market. And of course, what is the connection between money markets and the real markets, the real goods market? This is via this financing process, this credit process. And there we have this main variable of interest rates. So what we are now introducing is the money market and the new variable, interest rates. So to speak, in quotation marks, we start to introduce some price which can adjust if we interpret interest rates as the price of credits. But the general production price, 30,000 euro for one car, these are still fixed. So, introduction. Of money market and interest rate. So, and this model is called the ISLM model. What is the origin of this name? Well, the goods market at which we already looked, at this market we have just the equilibrium condition investment equals savings. Look at this, compare this with YD equals C plus I plus G. So in general, we could interpret this as something like total investment. Then we can rewrite this as YD minus C equals I. Let's assume this as a I tilde. So private investment and government expenditure as an interpretation as government investment in general. So then what is this? This is my income. Income minus consumption, circular flow, is nothing else than savings. So this equilibrium condition y equals yd, we can then just rewrite by subtracting consumption on both sides as savings equals investment. And therefore, so to speak, we get from the goods market the equilibrium condition investment equals saving, and therefore in a minute we are deducing from this an equilibrium function depending then on interest rates, and this we call then the so-called IS function. So this is from the goods or commodity market. And also keep in mind, right now, this IS is our equilibrium condition. This is not the identity as we had it in the circular flow. So, and then we go to the money market. And in the money market, we also just take the equilibrium condition, supply meets demand, money supply. For this, we assume that the central bank can set money supply. We have talked a lot about this, and we already derived a money demand function in the topic when we talked about money in general. Well, why do we call this then LM? Also from English, liquidity preference as money demand and money supply, money is set, so LM. So this is the origin of the name of this model. Well, and all this you find more or less described in the general theory of John Maynard Keynes, but there you don't find any function. It is only text. And he has written this in the mid of the 1920s, and then I think in the 1940s, John Hicks, also a very famous economist, then deduced from this textbook the model which we are now presenting here in our lectures. Okay, then, now, what happens to our commodity market, our goods market, if we think there about interest rates as a new variable? And there we assume that now investment is depending on interest rates. And again, we think like in the case of consumption that this function depending on interest rates is split into one autonomous part, not depending on interest rates, and another part depending directly on interest rates with this number is negative. So investment should decrease if interest rates are rising. If interest rates are rising. And how can we motivate this? Well, of course. If interest rates are high, then credits are expensive, and then I would reduce my investment plans. This is then more or less something like the opportunity cost argument. So then I have these two alternatives. Should I take my million I have earned last year within my company? Should I invest this in new people, in new machines, in a new factory line or something like this? Or should I invest it just at the capital market and save it? The higher the interest rate I get at the capital market, the lower is the number of my direct investments in my company. Or in general, and this is Keynes' marginal efficiency of capital, we think about an investment possibility. And this hopefully you have done in your introductory courses in investing. So think of an investment project. What have you done then? At t equals to 0, you said, I have to invest some money. Let's say 100,000 euro. This is, so to speak, I0. This is my starting investment, and then you have written down there a minus. Yeah? Then you hope that in future, t equals to 1, you get out of something. Let's say it is 50,000 euros. And this is a long-term investment. And in the second period, you suppose that you get out of your investment project 60,000 euros. And then we pose the question, are you investing? As an economist, what is your answer? Yes, you say, well, okay, but I don't know, I'm not fully informed. I cannot say if I should invest or not. Even compared to the case that I get out in this investment plans 110,000 euros, and I only have to invest 100,000. So the first one would say, well, it's a great investment, 10%, great. But we have to take interest rates into account. And this means we say it depends on how high is the interest rate. So with that, our condition, this is then just the point, is my investing row larger or lower than 0? So I start with 100,000 minus. Then present value of the 50,000 euros after 1 year. So I ask, what is the value of 50,000 euros in 1 year if I have an interest rate of I today? So how much money I have to invest for a given interest rate today to get 50,000 euro tomorrow? And this is then plus 50,000 over 1 plus I. And here I make a star, and this star I explain in a minute. And the same I have to do with the 60,000. Then 60,000 over 1 plus I, and now squared, because investing 2 periods. And then I can say, okay, if I set this to 0, then this is just an equation, one not determined variable, I star. And how did you call it then the solution for I star? Hopefully you have done this. This is the internal rate of return. And then we get some number out of it. This will be something like, I don't know, 7% or something like this. Well, let's do just something, although I'm then running out of time, but let's do it the artificial intelligence. Sorry, this I have to reduce. Solve. What do I have? Minus 100,000 plus 50,000 over 1 plus x plus 60,000 over 1 plus x squared equals to 0. Enter. Oh, point, I was quite good. So this was just an example how to use all the helpful things. I think you get these questions and then you have to calculate it with a pen, and this takes 15 minutes or something like this. Well, what you need today, fortunately only, is this one here, that you write down the right answers, and then we have right now we have the possibility that I even don't have to type in this. I just said, well, 0 equals 2, and then everything is directly written down. But of course, you still have to know what to do. All the other things is the AI or the computer doing for you. So, then we get out, so to speak, we can calculate for all possible investment possibilities the internal rates of return. And then we compare these internal rates of return with the general interest rate within our capital markets. Then, again, rational guys, Homo economicus, we compare, is our internal rate of return of our investment possibility higher or lower compared to the interest rate we find at the capital market. General interest rate at the capital market. Well, and then of course, we add up, so to speak, all investment possibilities which have a higher internal rate of return than our benchmark. And then, of course, if we increase the benchmark, the number of investments is going down. And this is this general assumption of the so-called marginal efficiency of capital. So what time? 9:42. Okay. So, and this we just feed in now into our model at the goods market. What does it mean? This we are doing today. We are starting again with our y equals yd. Still in this diagram we have here C0 plus G plus now investment depending on interest rate. And let's start with one. We are assuming that interest rates have a level of I1. So this is then C0 plus G plus I of I1 plus Cy times Y. Then we obtain this equilibrium output. But this equilibrium output is now depending on the interest rate. Because this is depending on the interest rate. Y star of I1. This we put down in another diagram where we have interest rates on the vertical axis and income on the horizontal axis. So this is Y star of I1. Well, we have assumed that we have a special interest rate. Let's assume this level would be here. What happens if we decrease I1 to I2 within our model? Where do we find in our model interest rates? Well, only in the investment function. What happens to this investment if interest rates are decreasing? Yeah? It's going up, investments are going up. Then I moves up, I of I1 is lower than I of I2. I2 is lower than I1. This is this opposite assumption which we just deduced. Investments are negatively depending on interest rates. So this one is moving upwards. So we are then somewhere here. C0 plus G plus I of I2. C0 plus G plus I of I2 plus cy times g. Or again, only just a parallel shift. Conceptually, it is, of course, the same argumentation as we had it when we discussed change in government expenditure. Well, then we have a new equilibrium income. This we put down here in our other diagram. An increase of income. Well, and this value now is directly connected to a lower interest rate. Let's assume it is somewhere here. So in this case, we have here now a pair of interest rate and income. And we have here a pair of interest rate and income. So, and now, maybe this is the hard part. Now you have to think of that this thought experiment, what happens if interest rates are changing, you have to do for all possible interest rates. So you can also think what happens within my model when I take let's do it in green, an interest rate I3. What happens if interest rates are increasing? So I3 is larger than I1. What happens? Yep, shifts down. Nothing else. Y of star of I3, depending now on a higher interest rate. Well, and also you make the same thinking about all interest rates in between, and even higher and even lower. And what do you obtain? Well, of course, we are obtaining just a new function now connecting from the commodity market interest rates with income. New function y of I and what does this function represent? All possible pairs of interest rates I and income y if the commodity market is in equilibrium. And this I wrote down also here. Okay, all this took a bit long, especially the repetition of the Keynesian cross. So on Thursday, I have to go on a bit faster. And maybe you can just think of the money market, because we already, if you remember when we talked about money, that we said we had a positive dependence on income and a negative dependence on interest rates. And maybe you can, as a homework, already think about it. What does it mean? If we also think of that money supply is just a fixed number, and then we start where we use the diagram with interest rates and money demand, money supply. And from this, we also then deduce a function connecting interest rates and output, now just coming from the money market. Okay, thank you very much for today. And please